Okay, good afternoon. Welcome back. So we are working today on some geometry. We've talked about having two parallel lines cut by transversal. We talked a little bit about different ways to find that angles are congruent. We've talked a bit about similarity and congruence of line segments and angles and different things. We're going to culminate some of that today with a few examples of triangle congruence proofs. So the first thing I want to talk about is we're trying to prove something. So for example, in this case, we're trying to prove the triangle labeled ABC is congruent to the triangle labeled DEC. Now, what does that mean? Well, again, remember last week, where I was picking it up somewhat successfully, a copy of the triangle, and spinning it and setting it down on a different triangle and saying, oh, these are actually identical. If I pick this triangle, one of the two triangles up, and without stretching or condensing it, if I just rotate it, I can find a way to set it on the other triangle, and therefore they're congruent. I can also reflect it, right? So I could flip it, but I'm not going to change the dimensions of the triangle. Now, we're going to continue that idea, but we're going to not do it physically in the sense of actually lifting a triangle up and showing that it is identical. We're going to do it logically by saying that there are these series of statements that we're going to show to be true that then tell us, by virtue of those statements being true, that those triangles are congruent. And at the heart of what we're doing is trying to find our way to one of four congruent triangle postulates. And over the course of a few weeks here, we'll go over each of them. But we're going to start with one of them today. And we're not, in this lesson, we're not going to prove the postulates to be true. We're going to take for granted that they have been proven. And what has been proven is that if you have corresponding angle, side congruence, then triangles are congruent. So if we get corresponding angles that are next to each other and then a side that's exterior to those two angles, then we will have congruence. So let's take a look. Now in this question, as in many questions, what we will also get are some givens. Park it down here. So given C is midpoint to BE, that line segment, and AB is parallel to DE. Now let's talk about them in succession. What is important about these given statements, or where do they lead us? The first one should be clear. If to have C be the midpoint between B and E means that these segments are congruent. So we often identify congruence on triangles with correspondence by saying we mark it. So here I'm marking with the single cross line segment that those two are corresponding to each other. Okay, that's useful. And it immediately brings in this type of situation. What about the S part of it? If we have two sides that are congruent to each other, corresponding and congruent, then we might start thinking about what that side's relationship will be to other aspects of the triangle that we might know. So maybe we can prove all 3 of the sides are congruent pairs. Maybe we can prove a couple of the angles are congruent. We're going to start with this one. Okay. Now the secondary part that we're given here, the AB line segment is parallel to DE line segment. That's very useful. Why is that useful? Well, it puts us in a situation to be able to use what we learned the past couple of weeks about two parallel lines cut by a transversal. Obviously, these are line segments, but we've dealt with that before. We're just thinking them as portions of lines. We still get a series of angles that are equal to each other for different reasons. We can kind of start to identify them, right? Let's start now with AB parallel to DE, and we'll look at the transversal BE. Okay, so what does it cause? Well, it causes these alternate interior angles, right? So that's very useful, right? They correspond to each other. Those are two angles that are congruent to each other. Now let's think again about line segment AB being parallel to line segment DE. What else does it tell us? Well, it tells us this. Because those two parallel lines are also cut by the transversal AD. Now here is where things get interesting, okay? So we can talk our way through this, but in order to prove triangle congruence, we need to be very thorough and nuanced about how we know the things we're saying, okay? Now, some of you may be doing it in this style, some of you may not, but let's do it as a two-column proof. What we're trying to establish here are a series of statements that will lead us to a triangle congruence. So what we need to basically do is establish through a series of statements that there are two congruent angles and one congruent side that's exterior to those angles. Well, let's start. Let's start in the same way that we started before, when we were talking more generally. What we have here, I want to make the statement here where we said that this line segment is congruent to this line segment. So first of all, I need to label them properly. The statement is that line segment BC is congruent to line segment CE. And the reasons, reason, is that is the definition of midpoint. Okay. So we are told, so this is a relationship between things that are given and inferences that we can make from that because we know what that means. So we're given that C is the midpoint of BE. That means that if you split BE into segments, BC and CE, those are equal segments. Those are congruent segments. That is literally what being a midpoint means. So we write that as the reason. And you can also notice when we established these two angles being congruent, two pairs of angles being congruent, we use the same reason actually. So let's take a look here. Angle BAC congruent to angle CDE. So BAC congruent to CDE, you can see them. And we just want to write out what we know. Alternate interior angles of parallel lines are congruent. For the same reason, we get this. And so we wind up with the AAS postulate telling us that these two triangles must be congruent. But think about what we did for a second. Yes, there's this rigorous style of the two-column proof beneath here, but what we ultimately did was we looked at this picture and said, what do we know about these two given statements? Well, we know if C is a midpoint, those two segments are equal. We know if AB is parallel to DE, then we get a bunch of these congruent angles because parallel lines cut by transversal, right? The same parallel lines cut by two different transversals give us each, but that's okay. Then we're just translating that knowledge into a more sophisticated style so that it reads simply. We know that two segments of the triangles, separate triangles, are congruent because of the definition of a midpoint. We know two angles are congruent because they're alternate interior angles of parallel lines. We know two other angles are for the same reason, and therefore we get the triangles are congruent by the postulate. Now, what does congruence mean? Ultimately, what's fascinating about this is, see in our diagram here, we have three things labeled. Two angles and a side congruent to two angles and a side. That information alone tells us the triangles must be congruent. What that means is it's impossible for these three things to be true and have the triangles not be identical pairs, right? It's impossible to have these three things be true and not have the triangles be identical. So it's a little bit like a shortcut, but not quite. It's not really a shortcut to saying things are congruent. What it is it's necessary and sufficient to saying two triangles are congruent. If you know these three things are true, you know a bunch of other things are true by their virtue. So for example, because we know the three that are labeled, we also know that these are congruent. We also know that these are congruent. We also know that these are congruent. In other words, all angles and sides of both the triangles are congruent. They have corresponding things. We could lift triangle CDE up, spin it around, and lay it down on triangle CAB. And it would be identical. Okay, so that's what we're doing here. That's the... Let me leave it here for a second so you can look at that. Okay. So let's reset really quick. I'm going to erase all this and draw ourselves another triangle, couple triangles here. I like to do this fairly precise, though my computer is not behaving right now. Just so we can see somewhat what we're talking about. It doesn't have to be perfect, but it's nice to at least have the segments be straight line segments. Given R is midpoint to SQ, and ST is parallel to PQ. Prove triangle triangle PQR is congruent to triangle TSR. Okay. So can you do this? Sit with it for a second. What are we attempting to do? See the two triangles that we're trying to compare. One is kind of top and a little to the right, and one is bottom a little to the left. We're trying to say that those are identically sized triangles. They are congruent. Look at our given information. See it on the picture. Visualize it. Even if the picture isn't perfect, the given statements are true, so we can think about the picture in that way. So R is the midpoint to SQ, all right. PQ and ST are parallel. Okay. Now, what can we say? Well, I think the first thing is that these two segments are congruent. Why? SR is congruent to QR because R is the midpoint of SQ. What else do we know? We know that the angle PQR is congruent to the angle TSR because alternate interior angles parallel lines are congruent. We never want to lose sight of, just because they're line segments and triangles, that we have all these powerful results from two parallel lines cut by a transversal line, right? That is going to be happening in essentially every single one of these types of proofs. Nearly all of them. Not all of them, but nearly all. Can you finish it? Hopefully, yes. So this is an identical question to the prior one in the sense of how we show it, or how we can show it, with angle, angle, side. Because we also know that this angle is congruent to this angle. Let me mark that with 2 hashes. Because alternate interior angles of parallel lines are congruent. However, I want us to actually prove this using a different postulate, the angle side angle. Think about the difference here between angle side angle and angle angle side. Given that we have the two pieces of information we have, statements we've made here, statement 1, statement 2, we have sides that are congruent, we have one angle pair that's congruent. We could do angle angle side by establishing that angle P is congruent to angle T. What do you think it would mean for us to actually instead show the postulate angle side angle? Now the ordering here matters, right? In both cases, we're talking about one pair of sides that are congruent, two pairs of angles that are congruent. But they're actually describing something very different. In an angle side angle, the S is between the two angles, the sides between the two angles. In angle angle side, the side is exterior to the two angles. So they're not in between. So if we're going to do ASA here, we need to show these two angles are congruent to each other. So we get here angle side angle, right? ASA. So we need the statement SRT congruent to QRP. How do we know that? How do we know that? Take your time. Why is the angle SRT congruent to the angle QRP? The answer is direct, but sophisticated. Those two angles are supplemental to the same angle, right? Meaning the measure of SRT plus the measure of a certain angle is 180. The measure of QRP plus the measure of that same exact angle is also 180, and therefore they must be the same. What is the angle in question? Well, this one or this one. Notice the supplemental nature here, right? the yellow kind of highlighted part kind of recognizing that these two angles together are 180. Same for the other yellow highlighted part. But they're talking about the same second angle, right? So they must be identical to each other. And therefore, triangle PQR congruent to triangle TSR by the angle side angle postulate. So these are interesting, right? These triangle proofs. They usually have a lot of similarities. They usually have a lot of strategies that you can call on every single time. I think very, very important that you talk yourself through what is given, right? You don't want to fall into the habit of doing any type of math question where you're told some things about the problem and you don't take them really seriously. You want to understand the implications of everything that is true by nature of the problem. So in this case, these two given statements here, we need to take them very seriously. What does it mean for R to be the midpoint of SQ? What does it mean for ST to be parallel to PQ? What are the implications of that? What can you infer about from those in order to show the triangles are congruent? After that, it becomes a matter of kind of looking at the picture and what you're given, what you can infer from it. Does it get you to a postulate? We've done two. There are two other ones, side angle side and side side side, that we'll talk about next week. So it's a matter of kind of balancing between taking everything very nuanced and sophisticated mathematically and looking at the picture and recognizing where the things are, right? How do these actually line up, and visualizing like, okay, can I get this angle congruent to this? Can I get this side congruent to this other side? Can I get this angle congruent to this other angle? You know, if not, can I look at a different pair of angles? Maybe those two are congruent and I can show it. Maybe these two sides are congruent and I can show it. So that's what you're looking at. And in each case, it's very similar. There's only so many options. You're either showing that sides are congruent or you're not able to. You're either showing that two angles are congruent or you're not able to. If you are, then you start to look for the patterns. Once you start getting a couple, you're looking to fill the postulate here with either angle, angle side, or angle side angle today. We were able to do both in this final problem and get there. So thank you for stopping by. I look forward to seeing you next